The next topic we're going to talk about is power. And power is the rate at which electrical energy is converted into other forms. Our formula here is P equals VI. Now this voltage here is measured in volts. This current here is measured in amps. And power here is measured in watts. Now this is one formula we can use for power, but we can use the resistance formula to derive other ways of calculating power. For example, we know the formula for resistance is equal to voltage over current. Now if I take current here and I move it over, what I'll end up having is voltage is equal to current times resistance. And like we have over here, we know that power is equal to voltage times current. Power, let's plug this information in for voltage. So it's current times resistance times current again. And if we simplify that, that becomes current squared times resistance. Another way we could do this, put that formula back up here, resistance is equal to voltage over current. What if we instead swapped places? So now current is equal to voltage over resistance. We know that power is equal to voltage times current, so let's take this idea right here and let's plug it into our equation. So that becomes power is equal to voltage times voltage over resistance. Simplified, power becomes equal to voltage squared over resistance. So now we've got three different forms. 1, 2, 3. Three different forms to figure out the exact same thing based on what information we have. So let's look at an example question here. A 25 ohm light bulb is plugged into a 120 volt outlet for 15 minutes. How much energy is used in joules and how many electrons pass through the circuit? With any of these questions, we need to figure out what information does it give us and what is it asking for. Read through the question. Resistance is 25 ohms. Voltage is equal to 120 volts. We know that time is equal to 15 minutes, which is equal to 900 seconds. Now it asks how much energy, if it's asking for energy, we'll put a question mark there, and how many electrons. If we're talking about figuring out electrons, then we're simply trying to figure out Q. Okay. We'll start backwards. We'll try to figure out the electrons parts first. Now let's think about what that equation is. That equation is equal to current is equal to Q over T. This means we need current in order to use this formula. We don't have it. How can we figure this out? Well, let's look back to our previous slide. We've got this formula right here. So let's figure this out. R is equal to V over I. So we plug in our values. 25 ohms is equal to 120 over I. Eventually, current is equal to 4.8 amps. Now, if we've got 4.8 amps, we now can work through this equation. Let's plug it in. 4.8 is equal to Q over 900. Therefore, Q is equal to 4320 Cs. We've now answered the number of electrons. Now we need to figure out energy. Now our energy formula, let me just put a box, is voltage is equal to change in energy over Q. Now we've got two of these three pieces of information, so we can answer it. So 120 is equal to change in E over 4320. Change in energy is equal to 518,400 joules.